Hello everybody, welcome to this high-yield sample course from Dr. Polizio's Gatto's Guide to Biostatistics and Epidemiology for medical board exams, as well as random facts on cats. For the full course and videos, please see the website drpoliziogatto.thinkific.com, and if you just want the ebook, the link is shown here, and to contact me, it's drpoliziogatto@gmail.com. So today we're going to be talking about forest plots, a very common topic that is asked in exams, and how to interpret them. Really easy, simple, straightforward topic, but oftenly misunderstood. Again, one of those free mark topics. So again, remember guys, this is just a content page of everything that is covered in the full course. So today we are going to be discussing the forest plots right down there. All right, let's get into it. So what exactly is a forest plot? It's a tool that's used to analyze data from a systematic review, a meta-analysis, right? So what is a meta-analysis? Remember, you'll have, if you're going through your hierarchy of studies, you start from your case report, case series, case control, cohort, and then your RCTs, and then you can get a grouping of all these studies, say a grouping of case control studies, a grouping of cohort studies, a grouping of RCTs, or maybe a mixture of the two, and then you group them all up, and then what you do is you write a review, a systematic review, which is the next step after the RCT, right? So systematic review on a particular topic, and to analyze the systematic review, you're going to do a meta-analysis. And to analyze data from a meta-analysis, you do what's called a forest plot. All right, so that's what a forest plot is, and this is what it looks like. So let's see what this forest plot, what this systematic review was looking at. You're reviewing the results of a meta-analysis for an educational presentation. It looks at the association between a new oral contraceptive for cervical cancer. 5 studies report the odds ratio of developing cervical cancer on the new pill compared to a second-generation pill. The results are displayed below. Fine. So we know we're looking at the odds ratio. Fine. So this is all showing your odds ratio down there. And then we're looking at two things. We're looking at a new oral contraceptive pill, and we're looking at the odds with cervical cancer. Right? Fine. So anything generally that is greater than 1 means increased odds, right? Less than 1 going this way means decreased odds. So meaning anything on this side of the number line, right, over this null line, means there was an increased risk, and anything on this side means there was a decreased risk. Fine. So this is the meta-analysis, the systematic review that we did. We had 1, 2, 3, 4, 5. So we had 5 studies, and this is what their conclusions were. So remember, we said anything to the left of this line means there was reduced risk. So in this case, Carr, Bryden showed decreased risk. Anything that crosses the line, so for example this one versus and this one, means there was no difference, so meaning no difference. And this one also straightforward, increased odds. All right, makes sense? Anything that touches the middle line means no effect. Anything on the right side means increased odds or increased risk. Anything on the left side of the line means decreased risk or decreased odds. And then you've got this diamond over here. The diamond is basically a weighted conclusion of all of this. So overall, if you're looking at all these studies and you group them together, what is your overall conclusion? That is crossing the midline, right? And because it's crossing the midline, we conclude that there was no effect of the new OCP in increasing cervical cancer risk. And then you notice here, you've got different size of these squares. The bigger the square, the greater the weight of that study. And finally, this represents the confidence interval, right? So for example, if you see this one, it's a very wide confidence interval compared to this one, right? So remember, bigger confidence interval, or so I should say wider range, Wider confidence interval means less accurate, while a narrower one means more accurate. Okay, fine. So how are questions asked regarding forest plots? Generally, they'll revolve around one of these things that we've talked about. So for example, in this question here, which one of the trials showed a non-significant reduction in the incidence of cervical cancer? Meaning, which of these is touching the non-significant, right? Which of these is non-significant? Anything that's touching the midline, so meaning this guy's study as well as this guy's study showed there was no difference. Which of these showed there was increased odds? This one. Which of these showed decreased odds? This one and this one. What is the overall conclusion from the study? Look for the diamond. If it's touching the central line, means there's been no effect or non-significance. If it's on this side, meaning there is positive increased odds. If it's on this side, decreased odds. And finally, which of these had the widest confidence interval and was the least accurate? This one, right? Widest confidence interval. Which of these has the greatest weight? The one with the largest square. And yeah, I think that's about almost everything that you will be asked. Or probably one more thing you might be asked is about the I value. They're significant. So I is generally heterogeneity, right? Meaning how similar were these individual trials compared to each other for us to make a conclusion. Generally speaking, anything greater than 50% means significant heterogeneity, meaning the trials were not very similar. So meaning whatever we're concluding has to be taken with caution, right? Because whatever, say you're going to say overall the new OCP was not associated with an increased risk of cervical cancer, but there was a massive heterogeneity in the studies, right? Meaning the studies were not very similar, so your conclusion might not necessarily be accurate. All right, guys, so that's how forest plots questions are usually asked, and that's how you interpret the forest plot questions. Fine. This is essentially talking about what we just said. So forest plot, graphical display, a number of results from different studies, main method of illustrating results from a meta-analysis, we've talked about that. And then on the left side here is where you have all your studies. And then this one is looking at relative risk. And then we've talked about the size of this, right? The wider the line, the wider the confidence interval. The wider the confidence interval, the less accurate your result. The vertical line running through, this is your line of null effect. Remember, anything that touches the line means there's non-significance. Anything on this side means increased risk, or anything on this side means decreased risk. The I value talks about heterogeneity, and we said anything greater than 50% means lots of heterogeneity between the studies, and further investigation is needed to explain the differences. Yeah, I think that's everything. Oh yeah, finally, the diamond, right? We talked about this. This is the overall effect. And if it touches the middle line, the null effect of the null line, right? This central vertical line, if it touches that, it means there has been no difference, overall conclusion. And finally, the size of the boxes indicates the weight of each study. The bigger the box, the greater the weight. All right, guys, and that's it for the forest plot. And our cat of the day is the Abyssinian. Gorgeous cat from ancient Egypt, we think. It has this wild jungle-like appearance. Very affectionate cat and loves climbing high places. I always think of this cat as the Ethiopian highlands, so it loves just like climbing high places. Not very affectionate in the sense like they don't like sitting on laps, right? They need their personal space, but they do love to be around people. Very good for houses that can match their energy. All right, guys, thank you so much for watching this video. Hope you find it useful, and all the best in your exam.